than just an x in there, then I need to find the derivative of that inside and put it up here. Essentially, this is saying do the chain rule. Okay, but it is a very lovely thing, this formula, and we're going to use it when we go backwards, when we do integration in a little bit, which means we're going to go backwards and try to get the function from the derivative. We're going to kind of use that thing. All right, so let's do these a couple different ways. So these you have right in front of you, up on the top. I sadly have to slide them under there. And so I'm going to do A, and A says, okay, I've got 3 ln 2x, and in these directions they say differentiate the following functions by first simplifying using log laws. So I'm assuming they mean 3 ln, I'll put a big bracket, 2 plus ln x. Is that all right? When I have a product here, the rule says, right, if I have a product, the rule says I can split it into a sum. Yeah? So I can split a product in here into a sum, and that's 3 ln 2 plus 3 ln x. Now, that thing is just a number, isn't it? A number I could type in my calculator. There's no variable there. So when I take the derivative and I get dy dx, that's 0, because it's just a plain old number. If you need to write that, write it. It's just a constant. There's no variable there. Here's the one that has the variable. And what's the derivative of ln x again? Look up. Look up. What is it?
1 over.
Yeah, so it's 3 over x. It's 3 times 1 over x. So I've got to know that rule of ln x is 1 on x. So this is just 3 on x. Okay, now what if I didn't use that? Okay, so for the next one, I'm going to kind of use just the chain rule here. So here I've got y equals 3 ln of x to the 1/2. Do you agree? Instead of square root, I'm going to put a half. And now I'm going to do this process where I say, okay, well, I'm going to do the rule. And the rule says that I put 1 over whatever's in here. So I'm going to go dy dx equals 3 times 1 over that. So this. But then I have to multiply by the derivative of that thing. I have to do the chain rule. What's the derivative of x to the 1/2? Half x to the negative half? Okay. Wow, that's a lot of stuff, isn't it? How am I going to simplify that? What is remaining on the top of the fraction when you get down to it? Just the 3. And I have an x to the half times an x to the half on the bottom. When that goes underneath, it becomes positive. What's x to the half times x to the half? X to the half times x to the half. What? Just x. And there's a 2 there. That 2. I know, it gets really squirrely. All right, I'm going to show you a different way to do that. Do we have room anywhere? Do you have some room underneath here? Maybe under here? Okay, I'm going to show you a different way. How about this? How about y equals 3 ln x to the half, and using this rule here, this rule here, this one, where you can take the power down the front. See it? So I have this situation, and I'm going to turn it into that situation. So I'm going to go, okay, I'm going to take the 1/2 down here. So now I have 3 over 2 ln x. Took the half, and I multiplied it by the 3. That is 3 on 2 times 1 on x. Oh, dy dx. I take the derivative, it's 3 on 2 times 1 on x, so it's 3 on 2x. Same? Okay, so there's a lot of different ways to think about these. The big deal is that you're going to have to say, every time I see an ln, it's going to be 1 over. We're never going to ask you to take the derivative of log base 2, or log base 5, or log base 10. Only ln. Okay, it's the only one we know. It's not true. It's the only one we use. All right, here I go. So now I'm in the situation kind of this, where I have a function inside here. I have 3x plus 2 inside the log. So there it is. So what does it say up there? F dash of x equals, and it's that fraction. So it's 1 over that. That's the rule, 1 over. And then times the derivative of that goes on the top. What's the derivative of that? And I'm done. No crossing out. Okay, it just looks like that. So the inside does the rule, which is the derivative of ln is 1 over that, and then times that.
Is that the second row?
Yes. That's this rule here. Yeah? Your syllabus mentions this rule. But it's just the chain rule. All right, here we go to B. It says x is less than 0. Why did they have to say that? Why did they have to say that? Yeah, you can't have a negative in there. Yeah? So I have to say, well, that's a negative thing, so negative times a negative is a positive, right? So here I go. This is dy dx. The derivative is whatever's out here goes on top, 5 over negative 2x times by, what's the derivative on the inside? Negative 2. So those are gone, because this is like over 1, isn't it? And so I end up, yep, with 5 on x. How long's this video? Yay! All right, here we go. Tell me, dy dx. Now be careful. It's 7 over that. Okay. Ooh, you made me do it wrong. It's 7 over that. Then I do times the derivative of that. 3x squared. Okay, now that's over 1. So what's on the top? 21x squared over x cubed. Can you do any simplifying there? It's real funny, the log. It always boils down to x on the bottom, it seems like. Okay, let's use this rule, and then please let me get this video off. What do you reckon? Use the rule, the middle rule on the top. Okay, that rule right here, this one, says put whatever is in those brackets on the bottom. So I'm going to do that. 2x squared minus 5x plus 7. And what am I meant to put on the top? The derivative of what's inside. Done. It's pretty easy, isn't it? If you could simplify this, you could, but they're very rarely. It takes a really contrived question to get it to be simplified. Okay, the problems are at the top, 3.3. My work here is done. I'll walk around and help you.